Hi there, guys. This is Mr. Brooks. I know you might be surprised to know that, but let's get started for your final exam. Listen carefully on each question. Do your best. Make sure you show all your work. Here we go. Some of these starting off pretty simple. We're going to evaluate the expression, so just follow order of operations and to get your answer on number 1. Number 2, all you got to do is simply plug in -5 for the x in these two locations. And again, follow order of operations. Work in parentheses first, then square it. Whatever you get, then you're going to simplify the rest of that to one answer. On number 3, again, now you're simplifying. I want to make sure to remind you to distribute this 5 and multiply the 2 as well, and then combine like terms. And being multiple choice, that's kind of nice. So if you're not getting any of those answers, you know you did something wrong. Again, we're going to multiply this 1/2 to everything on the inside. Okay? And then you're going to solve for x. On number 5, we want to solve for y. So y is right here. So that means you want to get rid of everybody else first. So to do that, for example, I would subtract 5x all the way over here to the other side. And then you're going to divide by the 2. And your answers should look like one of these. Number 6, again, let's begin by distributing and multiplying that 2 to everybody there, and then get x's on one side and numbers on the other and solve for x. Let's take it over here to number 7. There we go. So we're just now, again, we're going to evaluate. You want to plug -8 in right here for x and solve this whole part. Number 8, they want to know the slope of the line. Now, this line, these points would be x1, y1, x2, y2. We've been doing that since your freshman year. And to find slope, which is letter M, you're going to take y2 minus y1, it's a 1 there, over x2 minus x1. Number 9, what is the slope of a line that is perpendicular to a line with a slope of 4? So if your slope is 4, or in this case, we like slope as a fraction actually, so we'd say 4/1, perpendicular slopes are going to be the opposite and reciprocal of each other. For example, if I had 3/2 for one slope, I would need -2/3 for the other. Okay, so you just got to flip them around and change the signs. Okay, number 10's got a scatter plot right here, and we want to determine which of these lines do you think would be best to describe the scatter plot. And now, page 2. We're moving on. Keep chugging away here, kids. Okay, direct variation on this problem, number 11. The variables x and y vary directly. If x is 1/2 and y equals 6, which equation best relates x and y? Okay, what does all that mean? Heck if I know, but all you got to do is remember that it's y equals k times x. They give you x and they give you y. Plug them in. Plug him in over there. Solve for k. So then once you get k, then you're just going to rewrite it. Y equals whatever number you get for k times x. And that's exactly what they did on these choices right here. Which ordered pair is a solution to the system? Basically, what they're trying to say is, right here, the lines cross. What are the coordinates? Which of these coordinates is that? Okay, number 13, we have an ordered triple. So, what you got to do is first pick two equations that you can get rid of a letter. Me, looks like it'd be easiest to get rid of the x here. So I'm going to multiply everything by 2, all the terms. So now you're going to have 2x, whoops, that should be a minus, minus 4y, sorry, plus 2z equals 12. And then bring this guy straight over underneath. Eliminate the x's, okay? And then you got to eliminate the x's on these two equations, okay? And you're going to get two two-lettered equations, okay? Hopefully you remember how to do this. There's a lot of work involved with this one. But once you solve and find the value of, say, if we're getting rid of x's first, you're either going to solve for y or z. And once you know one of them, plug it in one of your doubled equations. In fact, let's fix this up here a little bit. This is kind of a mess. So we multiplied the whole thing by 2, right? Just going to kind of zoom that out and bring it over here. So, like I said, we had 2x minus 4y plus 2z equals 12. I multiplied that whole first equation by 2. Then I have the negative 2x, okay, plus the 4y minus z equals 12. Now, let's take a look at what happens. These cancel out. Those cancel out because they're both positive, negative, both same numbers. So that just leaves me now with 2 minus 1z, which is just going to be z equals 24. So now that you know a value for z, that's great. It makes things a lot easier, okay? So now what you want to do is you can plug him into both equations here and now get rid of one of the x's or y's. Actually, yeah. So you're going to plug it back in, get rid of either the x or the y's, and then just start plugging in both numbers and keep working it to where you get one variable for each one. Okay, without me literally taking you through the whole thing. Oops, look how that stays right there. Huh, the guy doesn't want to move. Maybe we can erase him. Yep, we can erase him. Let's erase that and move on to the next question. Okay. Compound inequality, number 14. Somewhere around there. So we have two arrows, solid dot on -2, open dot on 0. Remember if this would be solid or open. Okay. This is going left, which means it's less than -2. This is bolded bigger than 0, so it's going to be greater than 0 or greater than equal to 0. Again, it all depends on if it's colored in or if it's not colored in. Which of these matches up to that inequality? Okay, which is a pair? Which ordered pair is a solution? All you need to do is plug each of these in for x and y, every one of them, and see which one works in the solution. So basically, when you work the left side, it should be greater than 6. If it's equal to 6 or if it's less than 6, then you know that's not an answer. So there's only going to be one of these that works. That's your task. Here you go, picture of the graph. We have a dashed line and we're shaded above. Which one of these lines is describing that? What are the solutions for this absolute value? So remember, you got to make two problems here. The first one is going to be just like what it looks like. Or you're going to say 2x minus 4, okay, is equal to -2. And you're going to solve each one for x. Okay, for number 18, we got to use the negative b over 2a to find your vertex and your axis of symmetry for number 18. Moving on to page 3. Okay, so number 19 here. This one you can put these choices into the calculator and see which one matches up. Okay, pretty simple there. This one you need to, number 20, you factor the expression. So you could re-multiply these together and see if you get this for an answer. That's one way of doing it. You'd have to do each one, but it's a good way to help figure it out. Or if you know your multiplication facts really good, what two numbers multiply to give you a negative 21, but would also combine to give you a negative 4. Number 21, we just put this in your calculator and find where it crosses the x-axis. On number 22, again, you're going to factor. So which of these, if you multiply them together, gives you x squared minus 4. 23, again, we're going to factor. So determine which one of those. This is when we could use the box. Okay, if you remember the box, we went like this. 9x would go there, 4 would go there. Then we take a times c when we get 36. It's our b. And you continue from there. On number 24, all we got to do is distribute this negative to everybody, so just change their signs and then combine like terms. $25, you just got to simplify. Again, make sure you distribute first and combine like terms. Same way with number 26, but if I were doing this one, I'd make a 3 by 2. So I'd put 2x minus 1 there, and then 7x squared plus 3x minus 5, and then multiply those two together, and these two together, and these two together. Multiply those two, multiply those two, multiply those two, and then combine your like terms. Your like terms should be in these diagonal boxes. So make sure you put those together. Just do what the signs tell you. Number 27, you just got to solve for x. Remember, you're going to take the cube root of the number once you're done. Okay, so in the calculator, you'd find a little x, the radical button, and it's going to let you put a 3 in there. In 28, you just got to solve it. You could put it in the calculator and off you go. And now page 4 of 104. At least it feels like 104. Okay, function time here. Okay, so they give you what each function is. There's f, there's g. You got to make g of 4. So you're going to take this 4 and you're going to plug it in for the x and g. Solve it all out, then plug that back in here for the g and the x, and continue to solve. Okay, which functions are the inverse? So remember, this is y, obviously this is x. Then you need to switch them around. Okay, switch them around and get it all solved out. Okay, number 31, standard deviation set. In your graphic calculator, you're going to want to go and hit Stat, and then Edit. Then you can put this list in. Okay, then hit Stat again and Calculate. and then you have to hit the enter button like 3 times, and that'll tell you, you'll find what your standard deviation is. 32 just wants which exponential growth function is graphed. So here is our graph. Which one is exponential growth? Which equation? And again, on 32, you could just put those in on your calculator. Okay? 33, you got your formula given to you right here you're going to need. This is for, alright, A is your number, this is your rate, T is your time. Which of those works out right for that? 34, just put that in the calculator. 35, make sure you solve that out, okay, for log base 3. Okay, 36, again, just chuck that in the calculator, see which graph matches up with your answer sheets. Alright, number 37, just ask which equation represents an inverse variation. So think about your variations that we've talked about. 38, which function represents in a graph. So just put these in the calculator and see which one matches up. 39, we need to simplify, and we could multiply those first, and the 5 and the 12, then the x to third and the other x there, and then the x squared and the x fourth. Remember, when you're multiplying base powers like y to the second times y to the third, we just add the powers together. Okay, number 40, we can't divide fractions, so the first thing you should do is leave the first one alone, but then flip the second one, and when we do that, it turns into multiplication. Now you've got some things to simplify with here diagonally. Okay. Number 41, same difference, just simplifying. It's funny, there's two 41s on here. The last one was 41, this is a 41. Okay, when you're adding these matrices, just add ones together that are in the same location. So 0 and 0, 2 and 2, 4 and 1, and then of course 1 and 3. (42), very simple. All you gotta do is multiply the 3 to everybody. Multiply them to everybody. 43, figure out the pattern and what the next term is. Same way in 44. Number 45, and this is page 6. Solve equation, add him over, then multiply by 5 over 2 to both sides. Or divide by 2/5 if you have a calculator to do that. Okay, you're to graph this equation. Graph it on here. Okay. And you got to label your points. So once you got this in slope intercept, identify the M and the B, and then graph it. 47. Figure out you can use graphing, substitution, or elimination. She does not care which. So if you want to graph it, put them both into y equals mx plus b, and graph it and see where they physically cross one another. Okay, 48. They want to know the axis of symmetry, so just put that in the calculator. Or you could use the negative b over 2a. It's your choice. Okay? And same with the vertex. And then you're going to draw the graph that you got on your calculator over here. 49, we need to simplify. Remember, you want to get rid of those little guys first. And number 50, again, is another plug and chug scenario. Okay? So hopefully you do well and take your time. Thanks for tuning in.